If you have not yet posted your second one, get in there and do that sometime today. What I'm going to do is at least show you what I'm doing.
So we'll still do an example of the graphing?
Yes. Thank you for asking about that. What I do after you guys have submitted your ICA work is I go back through and I find all the links and then I collect them into one place. So your lecture links at the top is always your one-stop shop for pretty much everything. As you're doing the work, now what I will do a little bit later today is I'll actually put the original file so that you can see, a blank copy of the one I handed out. You can hang on to the one you have so that you can see what all the other questions were. And so once I post this, then those are active links that will take you right through to that person's work. So it makes it so that you can easily find some of that and check and see what you got out of that. You'll notice that as I had people posting it, I asked them to show the work so that you could see where they were coming from. Just because they had an answer wouldn't necessarily help you. So did today knock any cobwebs loose? That was really the intention. So we wanted you to get in there and sort of figure out what you remembered, what you thought you remembered, and what you really remembered. All right, so we're going to move forward here. Couple questions. One of them was, there's a question about a homework question where you had to do the instantaneous, you had to do a graph. That's a real life situation, and we wanted you to see that. And we wanted you to see how to manage that. Let's look at that again. So I'm going to pull up a question that's like that out of the end of chapter. You guys did a good job with this. I knew that it was going to be slower today than normal. Normally, this is a 10-minute task per question. Because you hadn't been really interacting with the material as much as I would have liked and as much as you probably would have liked, it took a little bit longer. So that tells you the things you need to review. All right, so if I look at your textbook, read, study, and practice, and your textbook is where you can always go to read the textbook. Kinetics, select, measuring the reaction rates. Section 2. Here's a problem where they had a concentration versus time, and one way that you determine the rate of something, we don't have to know the order to find the rate. Rate just means change in concentration over time. One way to do it is to draw the line that's tangent to this. So let me take a second and look at that process. They gave a similar question here under table 13.1. And so you have a homework that's sort of similar to this. So I'm going to go into Excel. Paste that data in there.
How did you just paste that?
Magic.
Tried.
I selected the data and see how it was highlighting it individually. That told me that I was going to be able to copy and paste it.
Right.
And that it wasn't going to be a picture.
It pasted it all into one cell when I tried to paste it.
Yeah, I'm magical. I don't know. If it does that, but see, when it does that is if you can't see them distinctly. If it's making this all one line, then it would not separate them out. But I could see that it was distinctly isolating what this was clearly set up as a table. When they
in the homework, it would have been different because I'm in the homework version.
Exactly.
Okay,
so this is just a question, and so yeah, sometimes you just have to type it in. But I could see that this one was actually going to work pretty well.
And you put the titles up there as well?
Absolutely.
Okay.
When you do a graph, you always need to do that, and that's a second big thing. That Whatever is on your x-axis should be the left column. Whatever on your y-axis should be your right column. When you go to do your graph, you select the column and the data. If you don't select both of them, then it's going to graph oddly. Then we're going to insert a scatter graph. It'll look something like that. That looks weird. Make sure it's reading that as all this numbers. That's what I thought.
Wait, what did you?
See how it's choosing this is all part of the header? See how the blocks are different? That tells me it's not showing me all the data. See, I'm not seeing a data point at point 1. That's what told me that it was reading it oddly, and which is a downside to this. So here's another magical trick. I'm gonna cut. I'm going to come down here. I'm going to right click and paste special. One of your, oh, that was interesting. Okay, so now we're going to choose this. Insert scatter graph. And it's still not showing it. That is very bizarre. I actually go back the old-fashioned way. Now, one way to say, I mean, I could have actually just typed it in, which would be a crazy talk. I know. One way of fixing that, it may have been, it was originally interpreting it incorrectly. One way of fixing this is if I right-click on the image, under the select data, then you can tell it where you really want the data to be. I want to edit that because it didn't do it properly. I wanted the time, the name of it to be just that row. I wanted the X values to be all of that. I wanted my Y values to be all of that. So you can actually fix it. It's, in a manual way, or you could actually type it in, just, whichever you're too lazy to do. All right, so what we have here is a graph that is a curve. If you right-click on it, you do have the option of adding a trend line. This is clearly not linear. You could make it a logarithmic function to see if that fits. Okay, not so much. Polynomial. Second order doesn't work it. Third order, not so much, but it's getting a little better. Fourth order, fifth order, that's a pretty good fit. You can actually sort of play with it. Now, do they want you to do that? Yeah, maybe not, but that gives you a curve. So that's how you can make Excel do a little bit of the dirty work for you. Yes?
Does it matter if time is on the X or the Y axis?
It absolutely matters. And I've got them reversed, haven't I?
Because I have concentration on the Y and I have time.
Absolutely. I absolutely have it reversed. And I should have been paying attention to that. I was just so delighted that it was actually reading my data. Yeah, small. No, you're totally right. All right, so now we need to, I could select my data again. I would like to edit that. I would like my series X values to be that. I would like my Y values to be that. There we go. My series name could be concentration.
So right-click select data is how you're changing all that around.
Yes.
Okay.
And actually, it's not doing a bad job of fitting that. And again, you can play with that a little bit. There is another way of managing that. I could also have just selected the whole graph, gone up here to design, quick layout, and because it's non-linear, I would choose like layout 6, and then you can again add add in a trend line if you like. So the question here is, right now it's choosing linear. Let's try a power rule. Oops. One more time, right click. Add trend line. I would like that to be a polynomial. That's pretty good. All right, so fifth order. Since I only have one set of data, there's no point in having a legend because it's not really meaningful. So what I've done at the moment is just graph it. If I want to read it, and you are going to have to do that for your homework, then what you do is you're going to select this whole graph and you're going to move it to a new sheet because you want that to be as spread out as possible so that you can interpret it a little bit better. Now let's say that I needed to know what is the instantaneous rate at 150 seconds. Well, that means that I need to draw a tangent to my curve. Now, you could print this out. You could take a ruler and do this however you want to do it. I just use the tools that are in Excel. One of the options that I have is to insert a shape that's a line. And I can draw a line in Excel. And I can drag it wherever I want it to be. Now, if it's a tangent line, what that means is that line should touch my curve only at that point. And it should be equidistant from the line to the curve, pretty close to it. So right now my tangent line isn't very good because it's touching more than one place. So you sort of twiddle with that a little bit. Do you get it to show up where you want it to be? Drawing a line that's tangent is a little bit of an art. And so nobody says it's going to be an easy thing to do the first time. But that's a pretty good one. It looks like it touches right there. Really close to it, it looks like it's fairly equidistant. As you get farther away, that's not going to be a rule. That's not going to be true. But as you get further, or as you get pretty close to that point of tangency, the gap between your line and the curve should be fairly equidistant on both sides. Does that make sense? Now, I need to read that line to determine my instantaneous rate. So what I'm going to do is I'm going to make this into a document that's easier to read. If I choose my axis, all I've done is I've gone over here, I've clicked on one of the numbers, right click, and I'm going to add minor grid lines. I'm going to do the same thing over here. I'm going to choose it, right click, and add minor grid lines. You've now made this into a measuring device. So I'm going to take a picture of this measuring device so I can write on it.
What was it called?
Minor grid lines. Now, just like any measurement tool, we have a number, we have marks, and then we have between the lines. Now, to make it easier, I'm going to try to find one that is pretty close to an intersection point, and often you'll have that. Like this data point right there is a perfect intersection of that grid. My drawing might not be, but that point is. And there's another one. There's almost always two that are exactly at an intersection point. They're just easier to read. Since you're determining the equation of the entire line, it doesn't matter where on the line you choose the points. So make it easier on yourself. So if I were to read this then, I would say n equals 0.04. I've got, this is m equals 1, m equals 2. It's on the third line. And I know what they're worth. How do I know? Because the markings are worth my range over spaces. My range is 0.02. Spaces between 1, 2, 3, 4, 5. 0.004. Right? Would you agree that the purpose of these lines is to divide that range into those 5 subdivisions? Yes? So that's what I'm choosing. I'm choosing a range of numbers. I'm counting the spaces between. And that will give me the value of each of those tick marks. So will this. If I go back to my graph, right click on this and format that axis. Oh, look, my minor grid lines are all worth 0.004. Ta-da!
A lot.
So you can do it the old-fashioned way, which is to take your range divided by the spaces, but you can also choose the grid lines to be whatever you want. Oh yeah, oh yeah. Assuming that I actually started it, which I'm pretty sure, yeah, a long time ago. Yeah. So I'm gonna do the same thing here. My n is, so counting, I know that they're worth 0.004. So 0.04 plus 3 times 0.004 is 0.012. 0.052 is my x coordinate or my y coordinate. This data point also has an x coordinate. I know it's 100 plus 1 mark passed. If I look at it, and again, I chose the intersections because they're the easiest points to read. If you're lucky enough to do that, go for it. Sure there are. Well, it looks great on my screen. The minor grid lines, you can change the colors of them. And let me show you that. Oops, wrong one. Go back, yeah. Can you see them on this graph? Okay, so let me, you totally can on the mother screen here. But you can actually change that. If I right click, I can format the axis and I can change what things look like. For example, I can change what my format the grid lines. I would like that to be black. Can you see it now? Oh yeah, well that's just because I only did that one axis. I'm gonna come back here, I'm gonna choose the axis, I'm gonna choose one of those, there we go, there's the grid lines. I'm gonna right click, format the grid lines, and I would like those to be black. So if you can't see it, now on my screen it was, yeah. So on mine it was super easy to see, and on yours when you're looking at it your screen, you'll see it also. You can choose, you can change any of these grid lines. You can format those grid lines to also be black, just so you can see it more easily. And now you have a very easy graph to read. So when I look at mine, my range is 150 minus 150. I had 1, 2, 3, 4, 5 spaces in between. So apparently each line is worth 10. So this one is 110 is my X reading and 0.052 as my Y reading coordinate. Then my slope is going to be y2 minus y1 over x2 minus x1, where this is 290.024 as my coordinate. And then I can work from there. Does that make sense? So I wanted you to see the walkthrough of that, and of course I record what I do in class so that if you need to go back, you can. All right, so that is that question. What questions do you have that are still hanging over from the ICCOs we did today? This would be a good time because we're going to move on. No carryovers? All right. So I wanted you to see just some review stuff, and we're gonna move into chapter 14 here. Don't have a ton of time here, but maybe we don't do as much 14 today. You're doing your first group lab this week. The group lab analysis is actually pretty easy once you get to it, but it's very detail oriented. What happens is, well, first off, you go to in your lab manual, you will find that there's a reading that is all about qualitative analysis. So it's the very last section of your lab manual. And the first portion of it is the overview of qualitative analysis. This is several pages, might be 16 pages. It could be less, but it's not hard reading. a lot of it is stuff you know in general, but it's reminding you of some basic lab techniques. As you're reading it, you might want to look at your group 1 pre-lab questions. Let me zoom down here. So your qualitative analysis talks about how to handle solids, how to heat something, flame test, all this kind of good stuff. So it's several pages of stuff. Because we're starting a process that's can be sometimes challenging. So this first group, as you're reading through this, be looking for these answers. Because these are the questions I want you to answer in your lab notebook before you get to class. Okay? So you're going to read through it. As you're reading through it, these are reading comprehension questions. It's just things that you need to look out for before you do the lab. Then it talks about the group 1 analysis specifically. This is the big picture of the group 1 analysis. In group 1, you're going to start with these 3 ions, and you're going to add some hydrochloric acid to it. Hydrochloric acid will precipitate these 3 ions out of every other ion, every other metal ion there is, because these are the only 3 ions that form insoluble chloride precipitates. Chlorides are usually soluble, except for these 3 things. So what we do in the first step is to precipitate them so that we can pull these ions out, and we call these the group 1 ions. They're not group 1A off the periodic table. They're just the ions that precipitate the most easily out of all of the ions on the whole periodic table. So we pull them out first, and if we needed to carry the other ions on to the next group that's a little bit harder to precipitate, then we could. This first week, we're only going to be looking at these 3. So we're going to precipitate them. And then we notice that by adding some hot water to it, the lead actually probably is going to redissolve, because lead isn't that insoluble. For that reason, you'll notice that they also show lead over here. They say that maybe some of the lead didn't fully precipitate, so you have to test the solution here and here to see if you have lead. Now, if you had a group 2 ion in the mixture, then you couldn't test for lead at this point. Would you agree to that? Because group 2 might precipitate as well. Why? Because we're adding chromate, and chromate precipitates just about every metal. So by adding chromate, we could guarantee we're going to precipitate lead, but we're going to precipitate every other metal in our mixture too. So we can only do this if we only have a group 1 ion. And that's what it says. If we only have group 1 ions, then add the chromate, because it's possible that none of your lead precipitated because we're in Florida and it's hot. And so it may be that our mixture was just too hot to precipitate very well. So if it did precipitate, adding the hot water should get it to redissolve. And then we can, again, add some chromate to it. If it precipitates, then you know you had lead. You're going to have one of the 3 ions. But I'm going to ask you to run a known mixture, one that has all 3 of them in it, and you're going to compare it to yours. Yours isn't going to react all the time. Why do you do the known and the unknown? What's the purpose of doing the known? So you know what it should look like. Because in the reading, it might say canary yellow. Well, you might not know what canary yellow is, and it depends on whose canary it is. So the point is that it may not look the way you're anticipating it. So you do the known so that you know, okay, this is what it should look like. They can say, oh, it precipitates in abundance, and you're looking at it as like a couple specks. So don't believe everything you read, is what I'm saying. So you run your known simultaneously in a different test tube, obviously. So the things that didn't dissolve are the mercury and silver. So to them, you're going to add ammonia and a little bit of water. And what will happen is that the silver will dissolve. How do I know it's dissolved? Because see how it's shown as an ion now? The only time you could have a separated ion is if it were aqueous. So this is the big picture. Then in the procedure, and this is the big picture for group 2. And I gave you the big picture of group 2, part B, and big picture. So the overview is what the big picture of what's happening in each of the groups. Then we get a little bit more granular. We look at much more detail for group 1. In the big picture, I said you're going to add some HCl. In the granular picture, we're going to say exactly how much we're going to add and what the concentrations are going to be. Do you see the difference? So the overview shows you what's happening to the ions as you're processing them. This is showing you exactly how much you have to add. So the second part of your pre-lab is going to be to copy this flowchart into your lab notebook. This is your procedure. So when you do the group analysis labs, your procedure is very simple. It's going to be show me what flowchart you're going to be following. And so a couple symbols in here you may not be used to seeing, you might want to make a note about. GTT means drops. It comes from the Latin word gute. Anybody who works in a pharmacy has seen that. If you don't work in a pharmacy, you might not have seen it yet. So now you know, that's the correct abbreviation for drops. PPT, what's that mean? Precipitate. It's the solid that forms. For this solution, the potassium chromate, the traditional procedure has you using 0.5 molar. You probably have 0.1 molar in your tray, and that's adequate. It doesn't take a lot of chromate to get something to precipitate. And so 0.1 molar is totally okay. I just want to make a note of that. In the process, it tells you to take the solution. Okay, so you take this solid that's silver and mercury, you extract 2 times with 4 molar ammonia. Just a reminder that ammonia, aqueous, is the same thing as ammonium hydroxide, aqueous. Because ammonia by itself is a gas. You probably remember from Chem 1 that if you had this substance, it would decompose and make ammonia gas and water. We're just reminding you that it's possible to trap it in water for a little while. So it's possible that it's labeled in this way, and you might want to make a note of that to yourself. The word extract means to dissolve selectively. When you do laundry, you extract the dirt into the water portion and you leave the shirt behind, hopefully. That's what we're doing here. We have this residue. We add some ammonia to it, and selectively it dissolves the silver, but it doesn't dissolve the mercury. So the extract is the dissolved portion. Notice in my flow chart, I always put my solution on the left of a branch and my precipitate or my solid on the right side so that I can track what's going to happen. You might want to view each of these boxes as a test tube. You have this test tube, and this is what, and if I could type, that would say total. Apparently I can't. Just as a heads up, 20 drops is the same thing as a milliliter. That'll get you into the ballpark. So when it says add water till the total volume is 1 milliliter, if you already used 10 drops, how much more water do you need? 10 more drops of water. So just a heads up on that. You're going to be using a centrifuge for the first time, and doing some of the reading will remind you about some centrifuge safety. Watching the safety video probably got you some of that as well. So when they separate, that means you should have different test tubes. And that's why after the word separate, you see different blocks. This one says we have group 1 only. That will be the case for us. We actually don't have a general unknown in that you're going to be doing this term. So you're not going to be doing this. I left it in the flow chart for understanding what's happening overall. If you had metals from any other group, they could have been in the supernatant. But if you have group 1 only, you can test it for lead. Again, 0.1 molar is fine on that.
Are we able to leave out that box?
No, leave it in there because I'm just telling you that you're not going to be doing that step, but I'm leaving it in there so that you can interpret the post-lab questions. Does that make sense? All right, so extract means to add some liquid, mix it up, then pull the juice off, and the juice is the extract. So when I have this, I'm going to now have 2 test tubes. Now, one of them could be the juice I didn't pull off, so it might be the same test tube. I just have a new test tube for the solution, and I test that. So the process itself, honestly, should take you about an hour. Realistically, you're going to be anxious about it. It's probably going to take you 2 hours, but that's okay. That's normal. You're going to make a mistake. You might have to start over. So when I give you the unknowns, I give you about 3 times more than you actually need, so that if you had to start over, you could, and you'd still have time to do it. But if you read through the process, you'll see it's actually not terribly bad. One of the things you'll see in your reading is that the first thing you should probably do when you get into lab is start your water bath heating, because that's the challenge. So you take a hot plate out, you put some DI water in a beaker. It can be a joint hot water bath for your group if you want. So use one of your big beakers for that. Just make sure you use DI water because the lime bakes onto the software or on the glassware. All right. So questions, concerns, prayer requests about this. So you have a couple things to do for your pre-lab. One of the things you're going to have to do is you're going to have to read. Second thing you're going to have to do is answer the reading questions. And again, I would sort of pull those out so that you know you're going to be looking for them. Third thing you're going to do is you're going to copy your flow chart into your notebook.
Questions get done in the lab notebook as well.
Your post-lab questions, yes.
No, not the reading questions?
Oh, yes, yes. So all of this goes into your notebooks. Anything that's a pre-lab goes into your notebook because it's stuff that you need to remind yourself. The questions I asked you are, what things do you need to do before you start the lab? That should be a note to yourself in your notebook. I need to do this before I start the lab. Get the hot water heating. Just a reminder about litmus paper. Down here it says you're going to add 4 molar nitric acid until it's acidic to litmus. Just as a reminder that blue litmus turns red if it's acidic, because you have 2 different colors of litmus paper in your workbench. You use blue if you're testing if something is acidic. Use red if you're testing to see if it's base. So I would make a note of this. In fact, anything that I made a note here today might not be a bad thing to put in your notebook. Because remember, your notebook is a working document. It doesn't have to be pretty. It has to have all the stuff you need. So notes to yourself are totally acceptable. So your grade is going to come from you're going to have a subjective score that comes from did you do your reading and answer those questions? Then your grade's going to come from, did you identify your unknown properly? And you have some post-lab questions that go with this. And then the rest of this is giving you the specific theory behind why are these things doing what they're doing. And so it's just describing your post-lab questions in general are reading based on that. So you don't do a full lab report for this one. For the group labs, they're just this. And there's one group 2, that takes 3 weeks to do. So you're not writing full lab reports during that time. That sort of allows you to devote your other time to, other material that we're covering. So questions, concerns, or prayer requests? Yes. No, those are pre-lab questions. Yes. So post-lab means after lab, you get a week to answer these questions.
And is the post-lab in the notebook?
Yes. Right. Does that make sense? I have updated the task list in Blackboard. I need to print out an updated version of your syllabus with an updated schedule. God willing, this will be sort of right, but we do the best we can. All right, so questions, concerns, prayer requests? Yeah, that's already on my list. All right, then I will see you guys on Wednesday.
I remember somebody talking about us